Today we begin our Systems of Linear Equations unit. A system of equations is just a collection of two or more linear equations. When we have systems, we have solutions. The solution to a system of linear equation is where the two lines intersect. What we're going to learn today is how to find that solution, that intersection, by the substitution method. So first, there are three different types of solutions. We're going to have one solution where they intersect at one point. We'll have no solution, and this happens when the two linear functions are parallel. So they don't intersect, therefore there are no solutions. And then we have infinitely many solutions, which means the slope's the same, the y-intercept's the same, the two linear functions intersect at each and every point. Therefore, all of their points are solutions to this system. So this is our first problem. We have y is equal to 3x plus 6, y plus 7x is equal to 2, and our goal is to find the solution to this system. Our first step is, if one equation is solved for a variable, we're going to use the substitution method. So this goes for all of the systems that you get. Here we have y is equal to, it's already solved for a variable, therefore we're going to be using the substitution method. And what we're going to do first is we're going to substitute what y is equal to in for y in the second equation. And the reason we're doing this is so we can have x's. We can combine our x's and solve for x. So that's the goal here. We're going to go ahead and solve for the only variable present now, which was our goal, just by combining our like terms first. 10x plus 6 is equal to 2. And we solve for x using our inverse operations to get the final answer. X is equal to -4 over 10. Now we only have one solution, one part of our coordinate, one part of our x comma y. Therefore, what we have to do is take this value now and substitute it into either one of these equations. Either equation will work. So here we have the first equation. I'm going to substitute that in. I'm going to substitute x in for that first equation. So 3 times -4 over 10 is -12 over 10 plus 6. I threw that into my calculator and I got 2.4. Our final answer here will be -4 over 10, comma, 2.4. We can also use the substitution method for our word problems. We're going to encounter some real-world problems where you have to use systems of equations. So let's see this one first. Eric is trying to figure out how old his two math teachers are. Ms. Faraci and Ms. Stewart have given Eric 2 clues to figure this out. The sum of their ages is 76, and Ms. Faraci is 22 years older than Ms. Stewart. How old is each teacher? So what we're going to have to do here first is identify our variables. So I'm going to have Ms. Faraci be x and Ms. Stewart be y. And then we're going to create our systems of linear functions. So using our descriptive words are going to be useful here. So we have the sum of their ages, so x plus y is equal to 76. And then Ms. Faraci is, so x equals 22 years older, so 22 plus whatever Ms. Stewart's age would be. Since one of our variables is solved for, we're going to take this and substitute it in for x in our first equation. So we're going to have 22 plus y is equal to 76. We're going to combine like terms. 22 plus 2y is equal to 76. Use our inverse operations to get Ms. Stewart's age of 27. We're not done yet because we don't have Ms. Faraci's age. We don't have the x comma y. So we're going to go ahead and do that. We can do that in either equation. I chose the easier one, x plus y is equal to 76, in my opinion. You can choose the other one if you'd like. But I substituted in 27 for y, subtracted 27 on both sides, and Miss Faraci's age is 49. And I'm just kidding. I'm really not that old.